Okay, I'm James Alexander. I'm from the Open University. I'm going to be giving a talk today called Search, Rest and Play, which is about video discovery in a video archive. First of all, about me. I'm currently a developer on the Open University Digital Library project, which is sort of building on the work of the Access to Video Assets project, which effectively is what's being displayed in the demo today. So we've been working with the video archive for a while now, and we're kind of developing that further into a kind of larger context, because obviously the Open University has a lot of different collections. It has an extensive collection of video, which I'll be talking about in a minute, but it also has collections, a very large, in fact, a larger collection of audio content for radio programs, and also various other collections of physical and non-physical material. So what we'll be looking at today is, first of all, the challenge, which is how to make it easier for the staff of the Open University, effectively, to discover the content and to make it available for reuse. Because one of the drivers for the Access to Video Assets project I'm talking about is really about saving costs. It's about reusing video. And this is something that commercial companies do all the time. It's a really important part of their work in video, which is to reuse existing content and to work around existing content. So I'll give you some background to the task, briefly outline how Solr was used as a key part of the solution. There won't be much code here. There'll be a little bit of binary, but there won't be much actual Java code. In fact, I don't think there'll be any. There'll be a live demo, I hope, but I won't be using the Open University VPN, so it should go okay. And then there'll be a brief wrap-up and an explanation. Okay, so first of all, for those of you not from the UK, the Open University is the largest university in the UK. It's got more than 250,000 students, and it's got more than 7,000 staff. It's also got about 3,500 academic-related staff, and it has a very large developer community as well. And we're looking at probably, I don't know, perhaps 120, 140 developers on the staff. And for those of you that don't know, the Vice-Chancellor of the Open University now is from Microsoft originally, and software development is something that the Open University takes really seriously. Again, for those of you not from the UK, the Open University and the BBC have a really long history. It goes back 40 years actually before the founding of the Open University. Originally, the Open University programmes were broadcast for the BBC, but that hasn't happened now for nearly 10 years. And what has been happening instead is that the BBC and the Open University have been working in partnership to create both course content and increasingly non-course content for consumption by the public and also by students at the university. So there's a reciprocal access to archives, and for most of the time this has involved BBC staff working at the Open University. And what we found in recent years is actually there's been a sort of a growing apart of that, so that actually there aren't so many people that now work for both organisations. Most of them now actually on the Open University site are Open University employees, and that's largely as a kind of an end of the broadcasting of content from the Open University. So there's over 9,000 TV programmes that are in the archive, and that equates to about 70 or perhaps slightly more thousand actual rolls of footage. So there's a lot of raw. You get a lot of raw material in order to make 9,000 programmes. That's a kind of. We haven't preserved all of the raw footage, but we've preserved a lot of it. We preserved all the programmes as far as we've been able to. And the BBC partnerships that we're currently undertaking include things like the OpenLearn site. So the OpenLearn site is effectively Open University courseware that's being opened up for public consumption, so anybody can use it. The Open University is committed to things like the Open Courseware Consortium, so that it makes as much of its courseware as possible available to the public free of charge. Now, of course, that's not a business model for development in the UK education world at the moment, but actually it's something it's been doing for a long time, and it will continue to do so. It's something that they're very committed to. So that's one of the BBC partnerships, because not all the content now that's made by the Open University is also by the BBC, but quite a lot of it is. Another one of the sort of media-related activities of the Open University is the release of content on iTunes U. So the Open University had about 40 million downloads from iTunes U, and it's one of the biggest partners that Apple has at iTunes U. So about the project, really. So, as I say, the idea of the Access to Video Assets project is really about enabling staff to get access to video assets to enable reuse and to save money. But also, it's about delivering a slightly more open university-specific thing, which is to preserve that video that we have, because, as I'll explain in a minute, a lot of it is in formats that actually aren't really very useful and are quite frail. And in order to do that, to develop a kind of a proof of concept repository, which I'll demo, for managing the digital preservation of that material. So the project did a lot of different things. Sorry, I should have gone to full screen. So one of the things it did was we digitized a lot of paperwork, which is perhaps not an obvious thing for a video digitization project to do, but actually there's an awful lot of paperwork that goes with every program. There's rights documents, there's transcripts, there's other content like subtitles, but paperwork, there's just huge amounts of it. For early things, there are things like camera scripts, which actually details the tea breaks that people used to take while they were making content. Obviously, they don't do that nowadays because TV production has moved on, I think, from that. But nevertheless, there's still a lot of paperwork. So another activity was to digitally preserve 1,400 programs, which now, to digitally preserve it, actually you want to save it at the highest possible resolution that is effective to do that. So the size of those digital files is kind of, for a half-an-hour program, it's about 60 to 80 gigabytes. We used an AVI codec, AVI wrapper for our material, but we could have used something else, but that's what we used. And that preservation has to take place, the recording of it takes place in real time. So that equates to 700 hours of recordings, assuming that none of it went wrong, which sometimes it did. So, and then there are also the creation of 2,700 or so flash movies for access. So that's really just for streaming media access to content, really. Okay, so what we did is we preserved a whole load of content, and there's a huge variety of different formats. And to start with, we started as a priority by saying we should preserve the oldest stuff. And then we got smart and thought, no, actually, we shouldn't preserve the oldest stuff. We need to preserve the stuff that's most at risk. And the stuff that's most at risk is the one that's in the kind of the most unorthodox formats. Because for video, although actually almost all of these forms, apart from D3, are non-digital, so they're all analog formats of tape. Some of them are quite common. So, for example, Umatic is actually quite a common format. It's not going anywhere. There are still thousands of players available, and you can buy one on eBay for, I don't know, $250. Whereas if you want to find a 1-inch Type A machine, then you can find one in the country, but actually, as far as we know, there is just one in the country. And when that goes down, then I think there's one in the States. There may be two, but actually we don't know that. It took us about 3 months to identify what a 1-inch Type A type was. All we knew it as was a funny 1-inch, because it's like a 1-inch tape, but actually it has a slightly different format, and it's the players are completely incompatible. So if you don't go to that Sussex garden to get your tape digitized, then I'm afraid in this country you just can't do it. And we work under constraints as to where our material can go as well, because obviously the archivist doesn't really like fragile material going very far, so taking it to the States was not a great option for that. But even some of the kind of slightly more common formats, and actually these are all more common than that, are quite fragile. So, for example, the D3s and pneumatics, those are things that are likely to shed material as they're digitized. So what you get is you get accumulation of content on the tape heads, and then the tape heads needs to be cleaned and stopped. And what you find is that, particularly on the lower formats, D3 and pneumatic, the tape heads wear out after a time. And D3s, I should say, a D3 tape is a format the BBC loved. The BBC loved D3 because it was one of the first digital formats. But actually the BBC were the only people that loved it, sadly. And most other people decided that actually they preferred Digibeta. And Digibeta is the industry standard, and it still is. But it was the option. Instead, the BBC got in about a year early, and they chose D3. Panasonic made D3, but actually they stopped doing that a long time ago. The tape heads aren't available anymore. The BBC bought them all up, apart from a few. And you cannot now get a D3 machine because the BBC continues to buy them up. So it's a kind of difficult thing, but they've worked very cooperatively with us in terms of helping to to preserve the material, but of course they've got a lot of their own content that they're also running through and digitizing. And they have a digitization factory, which is a really interesting experience to learn about. But it's a kind of large-scale factory, which ours wasn't. So since we're here, I should show you something of the content. So,
show you how to use the computer terminal at your study center.
This is from 1971.
Anything at all about programming, nor shall we deal in general with the faults which can arise.
This is digitized from a pneumatic tape, which is kind of fairly standard, but not of great resolution. So,
as you can see, it consists of a teletype, a telephone receiver, and a modem. And these are connected to a distant computer via a standard telephone line. The installation.
Enough. Okay, a 40-year-old computer, and you can see the tape there isn't in great. It isn't in great shape. You know, stop. There's a line down one side, and it's not a terribly clean piece of content. Not all the content that was broadcast was terribly good quality, but also things have deteriorated over time. So, and that's been a bit of an issue. Anyway, moving on from digitizing the content, what we did with it when it was digitized. So we looked at lots of different possible solutions for where we should put the content, and in the end, we thought we'll go for a Fedora repository. And there's a lot of background about that. We looked at lots of different systems, including other repository systems such as Greenstone, DSpace, Documentum, which is the university's default position, a number of commercial companies, although we weren't happy about putting it inside a proprietary system generally. And in the end, we chose Fedora basically for two main reasons, because it has preservation-friendly features, and we know that it won't interfere with the content. And secondly, because it's really flexible. It's flexible about describing the content, because there's a lot of associated content, as I've kind of said earlier. We've got a lot of paperwork. There's also a lot of other content cluttered around video objects. And also because it's flexibility. You know, if you can describe it pretty much, you can hold it inside a Fedora repository. And that really was its killer app for us, was that it's really flexible. It's quite robust and has a reasonably large developer community, and XML capabilities, which is kind of useful for the OU because we do a lot of stuff with open data, which I might have time to go on to. But really, it was about flexibility. And one of the key aspects of the flexibility is that it's agnostic about whether you hold the content inside the repository or not. And that's really useful for us. So there's an overhead with this, though, quite a big overhead, which is that Fedora is effectively a toolbox rather than a repository in the sense that DSpace or ePrints, you install it and you start putting stuff into it and you've got an interface. That isn't really the case with Fedora. There's a kind of interface, but it's not one you'd really want to use unless you're happy editing raw XML, which some people are, but not most of our users. So you build your own interface. It's got some APIs. They're good, but they're limited. And its concurrency is, when I say it's not good, I mean it's good up to 50 or 60 people, per second, but it's not great. So yeah, looking at building your own interface, we decided to use a Drupal content management system as the interface. Now, one of the reasons for this was simply that the Open University already has authentication and authorization systems for Drupal. It's kind of like already integrated in there, and we didn't really want to spend several months talking with our security officers about whether our installation was going to be secure or not. We thought we can use that module, and basically we've passed all the tests, so we can get on with actually doing the work. It's widely adopted at Open University. There's some other background as well, but I won't go into that. So now to make Fedora work with Drupal requires a little bit of work, because obviously Drupal is MySQL based. So the first thing you have to do obviously is knock out the nodes, because nodes belong to MySQL, not Fedora, and use it as an API rather than as a classic content management system used with MySQL. The odd thing is that actually it's quite easy to do that. You don't need to make a lot of changes to the code base. Because of Drupal's modular basis, you can actually just create your own module and pretty much take the content in on that using the API. You can override a lot of the code for the Drupal base, and you've still got the useful authentication and authorization aspects of it. So going back to that, as I said, the API for Fedora is also good but limited. And what we needed was we needed something else. I mean, first of all, I should say that almost all Fedora repositories have some sort of Solr interface, or some sort of, they're all pretty much integrated these days with Solr, or if not Solr, at least Lucene. But we needed something else in addition to that which Fedora gave us in order to actually make a useful interface, a nodeless interface. So one of the key things we need actually is we needed things like to be able to say how many results there were in a set, which Fedora's API doesn't give you, but obviously Solr does. So effectively what we've got is we've got a RESTful interface here. We've got a plugin for Fedora called gsearch, produced by Gert Pedersen, which is excellent, pushing repository content into a Solr index, and then we're pulling it out on a Solr PHP client. There is, of course, an Apache module for Solr, but actually to us that's not really useful because it integrates heavily with the MySQL. So actually that wasn't that useful, but we just used the JSON API, and that was just great. So Solr gives us content that would traditionally be stored and retrieved from a database, and it also gives us the features that Fedora can't. So, and it's kind of useful, although it wasn't essential for us to have the high performance and scaling for the proof of concept. In practice, that will be absolutely essential, if we were going to open it up to the world. So the other thing it gives us, which is not perhaps so obvious, is that it gives us a layer of mediation. Our archivist was really keen that we preserve the content exactly as it is, and we describe it exactly as it should be inside the repository. But that isn't the same as what we need to do to actually give access to that content. To give access to the content, we need to present it in a palatable and useful fashion, which is not necessarily the same as that enjoyed by archivists. Although it could be, it generally isn't. So putting it all together, if you ignore some of the arrows, it kind of looks a bit like this. So we've got authentication access, interface there. Basically everything is pretty much built around Solr, although in terms of pull and push the content. What we discovered as we went along was that although initially we developed it so that the individual records could be viewed and pulled straight out of Fedora, actually we shouldn't have done that really. It would have been a lot better just to pull all the content out of Solr because it would have given us much higher performance. It was fine to do that, but actually the more we use Solr, the better we like the REST interface, and actually the more useful we found it. So obviously because this is video, we've got a streaming media server over there, which is where our diagram differs from most other repository systems. And the other way it differs is that at the bottom there, you'll see that we've got all our stuff offline. We're holding 100 terabytes or so, perhaps more like 110, of content offline. We're not holding it online in a repository because we couldn't justify 100 terabyte spinning disk system for how often most of our content was being accessed. Most of it was not being accessed that often, but we know that within 10 years' time, it will be extremely cheap to put all that content online. So what we want to do is we want to keep it offline until it's reasonably expensive to actually put it online. And we can predict when that's going to happen. And we predict that actually we'll be able to purchase that system in 7.5 years for no particular exceptional cost. In the meantime, for the same cost, we've got a streaming media server which does all the access that we need. So that was an important thing for the project, was actually to say, we would love to have spent however many £100,000 it would be to actually put all that stuff online, but actually it would be a complete waste of money. So, the demo, yeah. So there'll be a brief view of these things, really. So navigation of a couple of views, some facets. I probably won't show those particularly because everybody here knows about those. Search and interface results and a bit of visualization stuff. So, okay, so we called our repository Fedora, and we called it that because it's Fedora and it's Ava, the Access to Video Assets project. So it wasn't very imaginative, but there we are. Okay, so the first thing you'll notice, apart from the fact that it's a very standard Drupal kind of interface, if you know that, this is a kind of very, it's called, I can't remember what it's called, it begins with G, the CSS for it. It's a standard Drupal theme, though. You see that most of our content, although it's gone off the page there, is organised in modules. So a module is what most other people would see as a course. So we did quite a lot of work in terms of analysis of user needs. We had a survey of 200 academic and academic-related staff. We did a whole series of workshops in terms of trying to find out what people did, what they used, what they understood. And so this is heavily orientated around the needs of academic and academic support staff, of which actually we have a lot of academic support staff, I should say, half as many as we do academic staff working at the main part of the campus. So it's a module-based view because that's what everybody wanted. They said, we must have it that way. You know, that's the most important thing to us. When we looked at the use of assets historically, the thing that we spotted was actually what was also really compelling was that people really need to see the stuff immediately in date form. And for reuse, it's really important to know how old something is because there's a kind of window for reuse, and it's about 4 or 5 years. Once stuff's more than 4 or 5 years old, it kind of looks old, and it isn't immediately useful for reuse unless it has either historical interest and relevancy or for some sort of pedagogical reason for our content. So it's not really that useful if it's older than, say, now, 2008. And we looked at what was being reused before, and we found that the cut-off date really was about 4 or 5 years, and after that, stuff was used further back, but it tended to be big names, things like, I don't know, Chomsky, T.S. Eliot, you know, really kind of like compelling content that had a historical interest in its own right. So there's dates, there's the modules, so these are course codes. I should say the modules here, modules A is stuff like, is from the arts faculty. C is actually co-productions with the BBC. It's not really, we don't really have anything called C. And S is science. So we'll have a look. So there's some content there. I'm not going to drill down through the facets here. I think the next thing to do is probably to as you can see, this is all, I should say, sorry, which the most important thing, obviously, is that this is all pulled out of Solr. Actually, there's no interface here with Fedora at all. All the content is in this interface is pulled straight out of Solr. Okay, so this is a bit, let's see if I make it a bit small. Okay, so now you can see the whole interface on. Yes, this is a detailed view of one record. You can see that we've got lots of tabs at the top there. You can also see we've got a video player window, which is kind of important. And we use Flow Player because it has lots of features that the other players don't, and you can adapt it heavily for various sorts of use. It also has subtitle integration, so you can do closed captions, and kind of like lots of other things. You can theme it very nicely. I'll go through some of the tabs in a second. Obviously, you can see there's a tag cloud over there, which I'll show you in a second. And you can see that we've still got faceted content down the right-hand side. And you can see that associated with this program, we've got a number of different things. So we've got different physical formats. We've also got different sorts of record types, which correspond to the tabs there. And we've got no presentation information, which is stuff about what happened when the thing was first broadcast. We've got other stuff like we've got a transcript, I think. Yeah, and we've got some physical media, and then we've got technical file information, which in this case is simply the information associated with the Flash movie there. So and then you can see we've got a brief outline of what the program content is down there. We've got no recording date on this because one of the things we spent most of our time on this project actually cleaning and munging data. It wasn't actually, most of the time was not spent digitizing stuff, it was spent linking stuff up, cleaning it up, you know, things like, trivial things like making all the dates the same format, you know, actually making the stuff match up because there was nothing obvious about making type transcripts match to program records. You know, there are corresponding things they have in common, such as the budget code, but actually apart from the budget code, they don't, and the same name often, but actually sometimes it's not the same name because when they typed it up, they had a slightly different name for the program than that which it was broadcast on. A lot of the things in video are kind of quite slippery. You know, it's not easy necessarily to tie all the things together with obvious identifiers. Generally, we use budget codes for content, but we spent a lot of time tying the content together, so it's kind of like a process of knitting stuff up, really, most of the time, as I say. So, yeah, so we've got those things. Facets we've done. A search, yeah, we should do a search, really, shouldn't we? Okay, so let's search for, I don't know, Pinatubo, because I know it's there. Okay, so we've got some results for Pinatubo, which is kind of like to do with the volcanic program. So the top result should be, and it is, volcanoes in the atmosphere, which is a program. This is, I should say, this is only this is a sample collection in here. There's only 40 videos in here, not all 9,000 of them. And then we've got a kind of a whole load of subtitles. Subtitles are really useful for search because, first of all, somebody else has done all the work for you. They've boiled down an entire program into about 500 or 600 words, something like that. Sorry, about 300 lines of content generally, so that it's a really useful précis of almost all the content. And we can prove that it's a really useful précis of almost all the content, because actually if you look at the tag clouds that are generated by a transcript and a subtitle, there's usually an overlap of about 85-ish%. Sometimes it's over 90, but generally it's over 80%. And the difference between the two is usually artifacts in the transcript, such as the names of people who are speaking. Yeah, there's a view of that particular subtitle, which is about the impact of the eruption. But much nicer than that. Sorry?
Do you have is there a link to be able to jump from a subtitle to this kind of where it is in context in the video?
Yeah, luckily we do, yeah. And here it is. Okay. Okay, so there we are. So what we did is we linked it to the context, because obviously we've got timings for that. But the really useful thing about that is that we've also kind of like, we're able to put the subtitles straight over the top of it as well. So it's a nice kind of thing to be able to do. On here, you can see there's a little flag for where the content occurs. And one thing with streaming media is that it's really important to actually start before the content actually starts streaming, because it can take several seconds, particularly over a network, for the content to actually come in as it starts streaming. So we usually started 4 seconds from the start of, before the start of the content. So that's what we did for that. So just going back to the main interface there. So the tag cloud basically does a kind of a more elaborate version of that. So we'd just click on that. And you can see that here we're pulling in, and this is coming straight out of Solr, we're pulling in content from there. So you can see we've got all the instances there of the word lava, and 4 seconds in we should get to it. Lava, there we go, okay. So, and it's quite a nice way of being able to see where that content is. We also did some work of trying to show on the words where the content was distributed, but it worked really badly. We thought, well, we could draw little lines through the words where it is, but it doesn't really work at all well because there are gaps between the letters, and it kind of like makes it really messy. So visualizing that further inside the tag cloud for distribution really wasn't a great idea. But actually putting it on the screen here works kind of reasonably well, and that more than satisfied most of our user expectations. So that was good. Because the other thing I should say is that the users really wanted to jump to where they wanted to the relevant part of the content. The academics didn't want to spend, say, 6 hours looking through 12 programs. They wanted to spend about half an hour looking for the various bits of content they wanted. And we looked at lots of other things, for example, in terms of making the text available. The academics were really keen when we surveyed them to make the text of content available. And they were really demanding that that text be absolutely correct. They weren't 97 or 98%, which is what you get from, usually from automated speech recognition, was not going to cut it at all. They needed over 99.5% accuracy. In fact, they wanted 100% accuracy, as they would get from a published book. And kind of less than that wasn't an acceptable thing for them. So I won't go through most of the tabs because I think we're not short on time, but we're just doing okay. But the other thing I did want to show you was that, in terms of visualization and interface, it's really important for people to actually be able to see the content, and also seeing a storyboard of content enables people to jump to a specific part of a video. So in this case, we've got a program, and it's one of the sample collection of 40. It is The Virtual Revolution, Homo Interneticus. So again, this is a BBC co-production. And what we did is we segmented it by time. So we took samples of the content every second using FFmpeg, which is a standard tool, and made that available, made each of the images available, and then we did a couple of things on that to kind of sort and sift them to try and find scene changes so that it would look a lot more interesting than just seeing a picture every second, and also make it possible to display it on the screen. So that really involved kind of like color analysis. We first of all threw away things that didn't. We threw away all the things that looked roughly similar in terms of an average color analysis, and then we sorted all the colors into about 10 or 12 buckets. And then if there were enough buckets were similar, we threw it away again. But if the buckets looked a bit different, we thought that could be interesting, we'll keep that. And actually, that really rough way of doing it was good enough to get us a scene change thing that's probably about 95% accurate. So this is without any human mediation. The other thing we did, which wasn't terribly successful, was we tried to get out the screens which were pure black. It's a lot more difficult than it looks to get rid of black because it's not always very pure black, but hey. So, for example, one of the scenarios we looked at addressing was the one in which, and it happens very often to us, say twice a week, is that somebody needs to find content about a particular interview. In this case, I'm going to try and find Mark Warburg because he's here somewhere. There he is. Yeah. So we used different interfaces for the video things just to see how they worked. So we should get him.
Version of Facebook in a couple of weeks in my dorm room at Harvard.
Sorry, Mark Zuckerberg. Yeah. So we used, as I say, a variety of different player interfaces because some work better than others. Actually, this is one that didn't work particularly well, although it looks very nice. It doesn't really standardise very well. And we also we played about with some of the other controls, things like being able to give the users fast forward and slow motion. But they really weren't interested in that, to be honest. What they really wanted was to be able to scan across the content of a video and see more or less at a glance where the content was or what it illustrated. The other thing it does, which is less intuitive, is it also gives you a very good idea about how old the stuff looks. And that's so important. Because if you can tell at a glance if this stuff looked too old, it just wouldn't be useful for reuse at all. It would be useful to preserve it, but it will be effectively a non-starter in terms of content. Sorry. Is there any way to get all the clips featuring Mark Zuckerberg? Yeah, there would be. The short answer is yes, there would be. I mean, we can't do it on this interface because we just didn't do it. I mean, you could do a text search on Zuckerberg, and one of the interesting things the Open University has also done is it's done a lot of image analysis in terms of entities. So, for example, actually facial recognition is not one of the things they've done, although you can buy that commercially and integrate it reasonably easily. But one of the things they have done is they've done entity recognition. So, for example, if you wanted to find, perhaps not Mark, but perhaps if you wanted to find a kettle or a picture of a bird, it could do that sort of stuff. So you could look for pictures of birds, and that isn't available integrated into this product because it was just too difficult. There's such a lot of image-specific search in that it really wasn't possible within the constraints of the program to do that. It's integrated into the work that's done for Pharos. There's a European search project called Pharos, and actually it's integrated into the Greenstone integration of that, which gives you some really smart things about finding particular objects of content. Okay, so about subtitles. Yeah, as I say, subtitles are great because somebody's done all the work for you. Unfortunately, you still have to do a little bit of work because subtitles come generally, although not so much nowadays, historically they come to you in a binary format, which is not great for working with. And it's called EBU, European Broadcast Union Standard, but there are so many different implementations of that that it's not nice, to be honest. You can't really work with that. But what you have to do is effectively translate it into another format. First of all, we had to translate it into two formats, one for preservation, because I should also say that when the BBC stopped broadcasting, they took their subtitling equipment with them, and most of it actually is redundant now anyway, so we couldn't use it. So we actually had no way of reading our own subtitles, embarrassing though it was. So we developed a way of reading them and translating them. So we translated them into XML for preservation, which gave us almost all the features that were actually in the original subtitle. And some of them have certain implementation-specific features, such as, for example, even if the subtitle extends across 2 frames, the timing only extends to the first frame, so that it appears as if you've got 2, one over another, one on top of another. Anyway, enough of that. Basically, we did all that, and we put it into Subrit, which is a format that can be used by most streaming media servers, and can be displayed, in this case, by FlowPlayer. And the XML stuff, we pushed that into Solr to make it searchable, and that was really straightforward. And we put the original content into the Fedora repository. And to say, one of the nice things about this is that, although we didn't do it this way, we could have just put the single XML file straight into Fedora, and then done all the splitting up work into in Apache Solr. So the tag cloud search example is a pretty straightforward implementation, really. A bit of JavaScript, you click it, Solr does the search. The trick is that actually we could have used some ActionScript programming here to generate the little location flags, but we didn't. We did it the old-fashioned way. We did it in ImageMagick, and that was good enough because we already had lots of images already, so that if the image didn't already exist, that's the one with the little flags on it, we generated it on the fly, and that was quick enough to work for us. And it generates this kind of like mainly transparent flag image. All you do is you just put the image at the back of the player. It's a really simple solution, but it works really well. It's really robust. To summarize, we learned a lot, really. We learned a lot about what things to prioritize, what things not to spend money on, because it's really easy to spend money when you're doing video preservation and access. So we learned a bit about that. We learned a lot about Solr, actually, in a year, enough to make it useful to us. As I say, we've used the learning from that project now in the creation of or at least the initiation of the creation of a kind of like broader digital library framework. So the things that you saw in the demo, such as the facets, we're reworking those because we need to work with a wider variety of content. So we're looking at a much more, I don't know if you're familiar with Blacklight, but Blacklight gives you a very useful way of navigating facets that's widely used in libraries for discovery of content. And we're looking at a much more Blacklight-based way. And although our academics said that they liked using a module-based view, actually, when you've got so many different formats of content, when we asked them about it, it just didn't cut it. They needed to differentiate, first of all, between things like an image and a subtitle, and then to look at the course, look at the context in terms of a course. One of the other interesting things about user interface was that when we asked them about what they needed, they gave us some really concise pointers. But when we sat them in front of a computer, nearly 50% of them couldn't actually turn the volume down very easily. So there was a kind of like a big gap between their expectations from the system and their ability to use it. So we had to make things really intuitive as far as possible for them to be able to use. It was kind of like a big constraint because there's lots of things you can build in, but if they looked at all clunky, we just knew that they were never going to get used. And that's really, I think, all I've got to say. So if there are any questions, then okay, well, thank you very much.